Can you believe it, that we might not be purely Earth-born humans? It sounds crazy, doesn't it? But wait. Let me ask you 3 simple questions, 3 questions that science, even today, still doesn't have fully satisfying answers to. First question, why did life appear on Earth so quickly? Our planet formed about 4.5 billion years ago. For the first 800 million years, it was nothing more than a churning ball of molten lava, relentlessly bombarded by meteorites. Surface temperatures reached 2000 degrees. Nothing could survive. And yet, just 600 million years later, life emerged. 600 million years sounds like a long time, but in terms of mathematical probability, it is almost impossible for even the simplest single cell to form by chance. Second question, why is 8% of your genome made of viruses? Not Earth viruses, but strange genetic sequences that resemble nothing found in any living organism on this planet. They have been there for millions of years, passed down from ancestors to descendants. So where did they come from? The final question, and perhaps the most unsettling one, why does every living thing on Earth, from tiny bacteria to massive whales, from plants to you, use the exact same genetic code? The odds of this happening randomly are 1 in a million. It is like flipping a coin 10,000 times in a row and getting heads every single time. These 3 questions lead to a conclusion that might keep you awake tonight. In the next few minutes, you may have to rethink everything you believe about the origin of humanity. Because the answer does not lie here, on Earth. It comes from out there, from the distant stars. We might be, quite literally, aliens. It begins with a question that even Charles Darwin, the father of evolution, could not answer. Earth formed about 4.5 billion years ago. Back then, our planet was a living hell. Molten lava churned everywhere, the surface an endless ocean of fire. The sky was not the clear blue we know today, but a thick orange-red veil filled with toxic smoke and dust. Average temperatures reached nearly 2000 degrees, hot enough to melt most metals. And as if that were not enough, Earth endured a relentless cosmic bombardment. Meteorites of all sizes slammed into the surface non-stop, hundreds of impacts every single day. Each explosion vaporized millions of tons of rock, blasting it skyward before it rained back down as fire. For the first 800 million years, Earth was nothing but a cosmic battlefield. No water, no atmosphere, nothing that could survive. Then, about 3.8 billion years ago, something extraordinary happened. Scientists discovered signs of life in the oldest fossils ever found. Not simple life, but surprisingly complex bacteria, capable of metabolism, reproduction, and adaptation. They were already there, truly alive, truly thriving. Do you see the problem? From the moment Earth cooled enough to sustain liquid water to the appearance of life, only 600 million years passed. That may sound like a long time, but compared to the staggering complexity of a living cell, it is unimaginably short. Darwin understood this. He devoted his life to studying evolution and knew better than anyone that natural selection requires time, vast amounts of time. Each evolutionary step is a small miracle, taking millions of generations for a beneficial trait to spread through a population. And that is just for minor changes, not for creating life from nothing. He called this the warm little pond problem. In his notes, Darwin speculated that life might have emerged in a small pond, rich in chemicals, energized by lightning, given enough time for molecules to assemble into living things. It sounded reasonable, but Darwin knew he had no evidence. He knew 600 million years was far too short, and he had no better answer. When we look at the numbers more closely, it becomes even more absurd. A single bacterial cell, the simplest form of life on Earth, contains around 4 million parts. 4 million. Every component must be precisely arranged, working together like a finely tuned machine. Inside that cell is DNA, a genetic code millions of letters long. There is RNA, translating DNA's instructions into proteins. There are thousands of different proteins, each performing a specific task, from transporting nutrients to generating energy to repairing damage. There is a cell membrane, an exquisitely engineered barrier that lets some substances pass while blocking others. All of this must exist at the same time. Remove just one part and the entire system collapses. DNA cannot replicate without proteins. Proteins cannot be made without RNA. RNA cannot survive without the protection of a cell membrane. The membrane itself cannot form without specialized proteins. It is a closed loop, with no obvious starting point. It is like walking into a junkyard filled with scrap metal, loose bolts, and tangled wires, and suddenly finding a fully assembled Boeing 747 sitting there. The propellers spin smoothly, the engines hum, the lights blink on and off. What would you think? Did it assemble itself, or did someone build it? Modern scientists have tried to recreate early Earth conditions in the lab. They mix the necessary chemicals, ammonia, methane, water, hydrogen. They fire electric sparks through the mixture to simulate lightning. They wait for months, even years, hoping for a miracle. The result? A few simple amino acids. These are merely the basic building blocks of proteins, nothing more. No complete proteins, no cell membranes, and certainly no DNA or RNA. The gap between chemistry and biology remains a vast, bottomless chasm, a mystery science has yet to bridge. So how did life appear on Earth in just 600 million years? Even 6 billion years might not be enough. Darwin did not know. Modern science does not know either. Unless life did not begin here at all. Unless it came from somewhere else, from a world far older than Earth. Unless the first cells did not randomly assemble themselves, but arrived fully formed, tested, proven to work across thousands of other planets. That sounds crazy, doesn't it? But sometimes, the craziest answer is the only one left. Every single day, about 100 tons of material from space fall onto Earth. 100 tons. Most of it burns up in the atmosphere, streaking across the sky as flashes of light we call shooting stars. People make wishes when they see them, unaware that what is falling could be evidence of humanity's greatest mystery. Some rocks do not burn away. They survive a hellish plunge through the atmosphere and slam into the planet's surface at thousands of kilometers per hour. We call them meteorites. For more than a century, scientists have collected thousands of them, hoping to find rare minerals or exotic metals inside. But what they discovered was something far more precious than gold, by orders of magnitude. In 1969, a meteorite crashed into the outskirts of the town of Murchison, Australia. Locals heard a thunderous boom and saw a blazing fireball tear across the daytime sky. Fragments scattered everywhere, adding up to more than 100 kilograms. Scientists rushed in to collect the pieces and bring them back to the lab. When they cut the stone open, they were stunned. Inside were 74 different amino acids. 74. Life on Earth uses only 20 to build everything from bacteria to humans. The remaining 54 found in this meteorite had never been seen before. They do not occur naturally here, and they exist in no organism on our planet. At first, many suspected contamination from Earth. Maybe the meteorite picked up bacteria or soil after it landed. But chemists looked closer. The chemical signatures of these amino acids were completely different. They formed in oxygen-free environments, at extremely low temperatures, under conditions found only in deep space. There was no mistaking it. Even more astonishing was the age of the rock. 4.5 billion years old. Older than our solar system. That means this stone existed before Earth, before the Sun, before even the surrounding planets were born. It drifted through the universe for billions of years, carrying inside it a collection of amino acids, the basic building blocks of life. And that was only the beginning. After Murchison, dozens of similar meteorites were found. The Allende meteorite, which fell in Mexico, contained nitrogen bases, the very letters that make up DNA and RNA. Without these letters, there is no way to store genetic information. Without genetic information, there is no life. Another meteorite, called Murray, carried sugars. Not the kind you eat, but special sugars that form the backbone of genetic chains. Every DNA molecule is a long string of sugar molecules linked together, like beads on a necklace. Without sugar, DNA cannot exist. Other carbon-rich meteorites carried lipids, fats that form cell membranes. A cell membrane is like the wall around a house, separating the inside from the outside and protecting everything within from a hostile environment. Without a membrane, a cell would fall apart like a drop of water in the ocean. Do you see the pattern? Meteorites do not bring just one ingredient, they bring an entire starter kit for life. Amino acids to make proteins. Nitrogen bases to make DNA. Sugars to form genetic backbones. Lipids to build cell membranes. Everything is there, drifting through space, waiting for the right planet to fall upon. But the story does not end there. Some meteorites contain something far more unsettling. When scientists used powerful electron microscopes to peer inside certain stones, they found tiny structures. At first glance, they looked like random mineral crystals. But under closer inspection, they appeared as tubes, spheres, and filaments. Their size, their arrangement, their internal organization all matched fossilized bacteria found on Earth. Not just similar. Identical. Sizes ranging from half a micrometer to 2 micrometers, exactly the size of bacteria. Tube shapes, rod shapes, spiral shapes, the same forms bacteria commonly take. They showed wall-like structures and internal features resembling cell nuclei. The odds of natural minerals randomly forming shapes like this are nearly zero. In 1996, NASA announced a discovery that shocked the world. They had found a meteorite in Antarctica called ALH 84001. Analysis revealed that it came from Mars, blasted into space by a massive impact millions of years ago, then wandering through the cosmos until it fell to Earth. Inside this rock, scientists found fossil-like microbial structures. They found complex organic molecules. They found traces of ancient life, life that once existed on Mars billions of years ago, before the planet became the cold, barren desert we see today. So what does this mean? It means meteorites do not just carry raw materials. They may carry the builders themselves. Living organisms, or at least the remnants of organisms that once lived. They carry stories of other worlds, where life once flourished and then faded, but never vanished completely. Preserved inside these stones, they travel the galaxy like messages sent to the future. Could these passengers survive journeys between the stars? Could they endure the -200-degree cold of space? Withstand cosmic radiation strong enough to tear molecules apart? Survive millions of years drifting through absolute emptiness? The answer lies with the strangest organisms Earth has ever produced. Creatures that make you wonder, when you see what they can do, whether they were truly born here at all. Meet Deinococcus radiodurans. The name sounds intimidatingly scientific, but researchers prefer a simpler nickname, Conan the bacterium. For a very good reason. This thing is almost impossible to kill. The amount of radiation a human can endure before dying is about 5 gray. Go a bit higher, and your cells begin to fall apart, DNA is shredded, organs shut down. But Deinococcus radiodurans? It can survive radiation levels of up to 15,000 gray. 3,000 times what a human can tolerate. 3,000 times. You can throw it into a nuclear reactor. It survives. You can place it next to radioactive fuel rods. It keeps reproducing normally. You can even send it into outer space, where cosmic rays slice through everything with brutal energy, and it just keeps going, as if nothing happened. The real miracle is not that it survives radiation. It is how it does it. When radiation tears the DNA of Deinococcus into hundreds of tiny fragments, it does not die. Instead, it activates an automatic repair system that scientists still do not fully understand. It gathers those shattered DNA pieces, reassembles them in the correct order, and restores its entire genome as if nothing happened. The whole process takes only a few hours. Think about that for a moment. Imagine a 1,000-page book ripped into individual scraps of paper and scattered across a room. Could you put it back together in perfect order? That would be nearly impossible. Yet Deinococcus does exactly that with its own DNA, with almost perfect accuracy, not a single letter out of place. It can survive in a complete vacuum for years. No air. No water. No nutrients. Give it just a little moisture, a bit of suitable warmth, and it wakes up and continues living as before. But here is the most important point. On Earth, Deinococcus never encounters radiation levels anywhere near that extreme. It lives in soil, in water, in places where radiation is low and safe. So why does it need resistance 3,000 times higher than necessary? Why would evolution develop such an extraordinarily complex system to defend against a threat that does not exist? Unless, the environment Deinococcus was truly built for is not Earth at all, but outer space. And yet, there is another organism that is even more outrageous. The tardigrade. Often called water bears, because under a microscope they look like tiny, chubby bears with 8 stubby legs. They are only about half a millimeter long and live in moss, thin films of water on leaves, damp soil. They look fragile. Harmless. Easy to destroy. But looks are deceiving. When conditions turn hostile, tardigrades do something almost no other Earth organism can do. They curl up, lose 99% of the water in their bodies, and slow their metabolism to less than 1% of normal. They become a tiny, rock-hard particle, entering a state that is neither alive nor dead. Not alive, because nearly all biological processes stop. Not dead, because they can wake up at any time. In this state, a tardigrade can survive temperatures of -458 degrees Fahrenheit, just a few degrees above absolute zero, a temperature so cold even air freezes solid. It can also survive 300 degrees Fahrenheit, where water boils away instantly. It can endure pressures 6 times greater than those at the bottom of the Mariana Trench, the deepest place in the ocean, where the force is strong enough to crush steel submarines. But the harshest test is not any of that. It is space. In 2007, the European Space Agency conducted a truly insane experiment. They sent a group of tardigrades to the International Space Station and attached them to the outside of the spacecraft, fully exposed to space. No air. No pressure. Temperatures swinging from -250 degrees to +250 degrees. Constant bombardment by cosmic rays and ultraviolet radiation from the sun, conditions that would kill any known Earth organism in seconds. 10 days later, they brought the tardigrades back and gave them a drop of water. 70% of them woke up. They began moving, eating, reproducing, as if they had only taken a nap. Nothing unusual. Nothing wrong. They had survived 10 days in an environment that should have annihilated all known life. Now think about this carefully. Where do tardigrades live? In damp moss. Thin layers of water. Garden soil. These are gentle environments, with mild temperatures, water, air, and food. Why would they need the ability to survive outer space? Why would they need to endure -458 degrees when the coldest temperatures they ever experience on Earth are only a few dozen degrees below freezing? Why would they need resistance to cosmic radiation when Earth's atmosphere already blocks it? Evolution does not waste resources. Every trait, every ability, exists for a reason. An animal that lives in the ocean does not develop wings. An animal that lives in dark caves does not need sharp distance vision. So why would tardigrades, living in such forgiving environments, evolve the ability to survive the most hostile conditions in the universe? When scientists analyzed the tardigrade genome, they discovered something even stranger. 20% of its genes do not match any other known organism on Earth. 20%. 1/5 of its genome comes from somewhere unknown, absent from the genetic databases of millions of studied species. It is as if someone took an ordinary organism and inserted a collection of special code designed to help it survive in environments that are not Earth, code designed for traveling between the stars. Are tardigrades living fossils from Earth's earliest biosphere, from a time when the planet was constantly bombarded by meteorites and blasted by radiation from a young sun? Possibly. But that still does not explain why their abilities go so far beyond what would ever be necessary. Or perhaps they were never Earth creatures to begin with. Perhaps they are descendants of cosmic passengers, organisms sent here from another world, pre-engineered to survive a journey lasting millions of years through the cold darkness of space. Life capable of traveling the universe truly exists. It is living right here on Earth. So the perfect conditions of our planet, are they really just a coincidence? Now let's talk about the unsettling coincidences of this planet, the kind that make you wonder, when you line them all up, whether any of this is really random. Earth sits 93 million miles from the Sun. That number sounds arbitrary, but it is the perfect distance. Just 5% closer and we would become Venus, where surface temperatures reach 460 degrees Celsius, hot enough to melt lead. 10% farther out and we would be Mars, a frozen desert where water exists only as ice or vapor. No liquid water, no life. 93 million miles. Not more, not less. Just enough for water to exist in all three states, solid, liquid, and gas. Just enough for sunlight to be strong enough to sustain plants, but not strong enough to burn everything away. Just enough to give us 4 seasons, a stable day-night cycle, and a climate that can be predicted. Earth's orbit around the Sun is almost a perfect circle. Its eccentricity is only about 2%. That means the distance between Earth and the Sun barely changes over the course of a year. No summers from hell, no winters like Antarctica. Everything is stable, predictable, suitable for life to develop over long stretches of time. Then there is the Moon. Our natural satellite is unusually large compared to the size of the planet. It is about 1/4 of Earth's diameter, creating a gravitational pull strong enough to stabilize Earth's axis. Thanks to the Moon, Earth's tilt stays fixed at about 23.5 degrees, allowing for clear seasons and a stable climate over millions of years. Without the Moon, Earth's axis would wobble chaotically, constantly changing direction. Sometimes the North Pole would point straight at the Sun, creating summers that last for years with terrifying temperatures. Other times it would point away, plunging the planet into permanent ice-covered winters. Complex life could never evolve under conditions that unstable. Our atmosphere is just as strange. 78% nitrogen, 21% oxygen. Sounds familiar, right? But chemically, this is a highly unstable mix. Oxygen is extremely reactive, it wants to combine with almost everything. Nitrogen is relatively inert, but when it mixes with oxygen at high temperatures, it can form compounds that trigger chain reactions capable of burning the entire atmosphere away in just a few centuries. And yet this atmosphere has remained stable for billions of years. Billions. It did not burn up, it did not disappear, it did not drift wildly in composition. It is as if some invisible regulatory system has been constantly adjusting the balance, making sure the ratios stay within the narrow range that life requires. The odds of all of this happening at the same time? Mathematicians struggle to put an exact number on it. They often compare it to flipping a coin 10,000 times in a row and getting heads every single time. Or buying a lottery ticket, winning the jackpot, then buying another ticket and winning again, and doing that 10 times in a row. Not impossible, but so unlikely it borders on unbelievable. And the story still is not over. There is a mystery even bigger than everything we have mentioned so far. 4 billion years ago, when life was just beginning to appear on Earth, our sun was younger and weaker. It was about 25% dimmer than it is today. 25% less light, less heat. According to every calculation in physics, Earth at that time should have been a completely frozen snowball. Average temperatures should have been well below zero. The oceans should have frozen solid from the surface all the way to the bottom. No liquid water, no life. But the geological record tells a different story. Scientists have found sediments from 4 billion years ago that could only form under liquid oceans. They have found bacterial fossils from that era, showing that life not only existed but was thriving. They have found evidence of rain, rivers, and a fully functioning water cycle. How is that possible? How could Earth stay warm when the sun was so weak? This is known as the faint young sun paradox, one of the biggest puzzles in planetary science. There are theories that try to explain it. Some suggest intense volcanic activity released greenhouse gases that trapped heat. Others argue the atmosphere was much thicker than it is today, acting like a massive blanket that protected the planet from cosmic cold. But every explanation requires a new chain of lucky circumstances, each one more unlikely than the last. Unless someone did something. Unless Earth did not warm itself naturally, but was kept warm by a process that was not natural at all. What happens when an advanced civilization, knowing their star is nearing its end, decides not just to send seeds of life into the universe? What happens when they carefully select suitable planets and actively modify them to be ready for life? You would need to adjust the atmospheric composition. You would need to stabilize the orbit, perhaps by placing a large satellite around the planet. You would need to create a strong magnetic field to block cosmic radiation and protect the surface for future organisms. You would need to calculate everything so that the planet stays in the habitable zone even when its star is young and weak. It sounds like science fiction. But we humans have already begun talking seriously about terraforming Mars. We have plans to give it an atmosphere, warm it up, turn it into a place that could support life. We have only had space technology for a few decades, and we are already thinking about reshaping an entire planet. So what could a civilization millions or billions of years old accomplish? Maybe the moon did not form from a random collision. Maybe it was placed deliberately into orbit to stabilize Earth's axis. Maybe our magnetic field, generated by a spinning molten iron core, is not a lucky accident but the result of careful design. Maybe even Earth's position in the galaxy was chosen, far enough from the galactic center to avoid deadly radiation, yet close enough to benefit from heavy elements forged by dying stars. Earth's conditions may not be random at all. They may be the result of a preparation project spanning billions of years. A carefully designed biological laboratory, waiting for the seeds of life to arrive, take root, and grow into what we see today. The evidence for this preparation may lie in fossils that are 540 million years old, where the story truly starts to get crazy. For 3 billion years, Earth was home to nothing but single-celled bacteria. 3 billion years. A stretch of time so vast the human brain can barely grasp it. Throughout all those ages, life on this planet was simple, tiny, invisible to the naked eye. Single-celled organisms drifted through the oceans, eating, reproducing, dying, repeating the same cycle across millions of generations. No eyes to see the world. No brains to think. Nothing more complex than a small sack filled with chemicals. Then, 540 million years ago, everything exploded. In a window of just 25 million years, a blink compared to the 3 billion years before it, nearly every major group of animals we know today suddenly appeared. At the same time. All at once. No warning, no gradual buildup, just a biological detonation, as if someone had flipped a switch. Trilobites were among the first. They looked like giant armored centipedes. But the truly astonishing part was not their shape, it was their eyes. Compound eyes, like those of modern flies, but far more advanced. Each eye contained 15,000 tiny lenses, packed together like a honeycomb. 15,000. More sophisticated than the eyes of most insects alive today. Each lens was a perfectly clear crystal of calcite, polished into an exact shape to bend light precisely. Each lens connected to its own nerve, sending signals straight to the brain. A trilobite's brain processed thousands of data streams at once, assembling a panoramic image of the world around it. This was optical technology that nature would not replicate in other creatures for hundreds of millions of years. Then there was Anomalocaris. This monster grew over 6 feet long, enormous compared to anything that had ever existed before. A long body, massive disc-shaped eyes on the sides of its head, flexible grasping limbs up front to seize prey. Its mouth was a complex circular structure lined with sharp teeth arranged in a ring, capable of crushing hard shells. This was the first predator on Earth, the first creature to actively hunt other animals. Opabinia was even stranger. 5 eyes on its head, looking in 5 different directions. A long flexible proboscis extending forward, ending in a small claw used to grab food and bring it to the mouth. A segmented body, each segment equipped with a pair of swimming flaps. Look at it and you would swear it came from another planet, not from Earth. All of these creatures appear in the fossil record as if they were printed by a 3D printer. Complete. Fully functional. With no simpler versions before them. No prototypes with primitive eyes or half-formed limbs. They are simply there. Suddenly. As if someone had just downloaded a complete collection of animal designs. Darwin knew about this problem. He called it the most serious objection to his theory of evolution. He understood that natural selection needs time, it needs gradual transitions. But in the Cambrian fossil record, there are no transitions. Only the sudden arrival of immense complexity. Imagine this. You are excavating an archaeological site. In the older layers, you find footprints of barefoot humans. In a slightly newer layer, you suddenly uncover a smartphone. No shoes. No carts. No telegraph, no landline phones, no room-sized computers. Just bare feet, and then suddenly, a smartphone. What would you think? Modern biologists have searched everywhere, hoping to find these transitional ancestors. Creatures with a simple eye that had not yet become a compound eye. Creatures with small appendages that might later evolve into arms. Creatures with rudimentary nerve nets that could grow into brains. They searched older fossils. They searched rocks from before the Cambrian period. They found nothing. Only a gap. A vast chasm between simple life and complex life. Paleontologists even gave it a name, the Cambrian Gap. A hole in the fossil record that no one can fully explain. The Cambrian explosion was not the only case. Earth's history is filled with similar sudden appearances. Birds show up in the Jurassic with no clear reptilian ancestors that reveal a slow development of wings. Flowering plants emerge in the Cretaceous without obvious precursors. Mammals diversify rapidly after the extinction of the dinosaurs, filling ecological niches at an extraordinary speed. Even stranger, these sudden appearances often coincide with periods of asteroid impacts. As if each collision did not just wipe out old life, but also delivered the designs for new life. Modern geneticists have analyzed the DNA sequences of different species, trying to reconstruct their evolutionary histories. What they found only deepened the mystery. Many major genetic innovations do not appear gradually along evolutionary family trees. They appear abruptly, often in multiple unrelated lineages at the same time. The genes responsible for complex eyes, for example, are remarkably similar across vastly different animals. Flies, squid, humans, all use closely related genes to build eyes, even though our eyes evolved independently along 3 separate paths. It is as if the same instruction manual was handed out to multiple construction projects. The nervous system, the digestive system, the circulatory system, all show the same pattern. They appear fully formed in the fossil record. They appear in many species at once. With no clear transitional stages. As if they were downloaded from a design library located somewhere beyond Earth. Traditional evolutionary theory explains these gaps by pointing to poor fossil preservation. Soft-bodied organisms do not fossilize well, they argue, leaving an incomplete record. But this explanation struggles against mathematical probability. Too many complex systems appear too quickly, too simultaneously, to be the product of random evolution alone. The hypothesis of life from space offers a different explanation. These sudden appearances were not evolution at all. They were biological seeding events. Each wave of asteroids did not just carry simple organic molecules. They carried complete genetic blueprints, designs that had already been tested and refined across thousands of other worlds before reaching Earth. Life on Earth did not invent eyes, brains, hearts, or lungs on its own. It inherited these designs from cosmic ancestors, from civilizations that solved these biological challenges billions of years before our solar system was born. But where were these blueprints created? The answer may be hidden in the clouds between the stars, where even now, a vast cosmic factory is tirelessly producing the building blocks of life. As you watch this video, something extraordinary is happening among the stars. Something most people never think about, never even imagine. Out there, in the cold darkness of interstellar space, life is being assembled. Vast clouds of cosmic dust stretch across light years. A light year is the distance light travels in a year, nearly 10 trillion kilometers. These clouds are not empty gas drifting aimlessly. They are colossal factories, natural chemical furnaces that never stop producing complex molecules. The James Webb Space Telescope, the most powerful telescope humanity has ever built, has turned its gaze toward these clouds. What it found stunned scientists. More than 200 different kinds of organic compounds, floating through space like pieces of a gigantic cosmic puzzle. 200 kinds, more than anything we have ever found on Earth. The Eagle Nebula, a cloud 7,000 light-years away, is one of these factories. Inside it is enough organic material to seed millions of planets. Millions, not dozens, not hundreds. Millions of worlds could be born from the material in a single cloud. The temperature there is -400 degrees. Cold enough that Earth's air would freeze and fall like snow. Cold enough that most atomic motion nearly comes to a halt. In conditions like that, you might think no chemical reactions could happen. You would be wrong. These clouds do not just create simple molecules. They produce long hydrocarbon chains, complex molecular rings, even structures that resemble primitive cell membranes. On Earth, we need advanced laboratories, carefully controlled temperatures, precise pressures to make these things. Out there, they form naturally in the brutal cold of space. How is that possible? The secret lies in tiny dust grains, smaller than cigarette smoke. Each grain is like a microscopic laboratory. Its surface gives atoms a place to meet, stick, and combine. Without these surfaces, atoms would collide and bounce away, never bonding. But on dust grains, they can settle, wait, until another atom arrives, slowly forming chemical bonds. This process unfolds slowly, over millions of years. A hydrogen atom sticks to a dust grain. Later, a carbon atom arrives and bonds with it. Then oxygen. Then nitrogen. One atom at a time, one bond at a time, complex molecules are patiently built. The energy driving this process comes from nearby stars. Ultraviolet light from young stars shines into the cloud, providing just enough energy to push chemical reactions forward without destroying their products. Like cooking over low heat, slowly and patiently, letting flavors develop without burning the meal. Over time, simple molecules combine into more complex ones. Amino acids form from basic elements. Sugars emerge from carbon, hydrogen, and oxygen. Closed molecular rings appear, laying the groundwork for biological compounds. Even membrane-like structures assemble themselves as fatty molecules line up into double layers. James Webb has detected long hydrocarbon chains, organic rings, and primitive membrane structures in regions of space colder than -400 degrees. These molecules are so complex that on Earth, we find them only inside living cells. Yet here they form naturally, without life, needing only time, dust, and starlight. The Orion cloud, another nearby cloud just 1,300 light-years away, is producing alcohol by the trillions of molecules. Not drinking alcohol, but methanol and ethanol, key compounds in biochemistry. Alongside them are sugars, amino acids, and even structures scientists are still trying to identify. These clouds are not rare exceptions. They are everywhere in the galaxy. Every star-forming region is also a molecule-forming region. The Milky Way contains billions of such factories. Billions. Each one producing biological material on an industrial scale, non-stop, for billions of years. The scale of this production is hard to grasp. Every second, these clouds create an amount of organic compounds equal to the mass of thousands of Earths. Thousands, not kilograms, not tons, but thousands of planets. Every single second. When a dust cloud finally collapses to form a new star, it does not lose its stockpile of organic material. Instead, all those complex molecules are concentrated and mixed into the spinning disk of material around the young star. From that disk, planets form. Asteroids form. Comets form. All of them carry within them organic compounds forged millions of years earlier in the space between stars. The universe is like a colossal 3D printer, running non-stop for 13 billion years, manufacturing biological components and distributing them to every corner of the galaxy. Every new solar system is born with a complete starter kit of the molecules needed for life. Not by luck. Not by chance. But as an inevitable part of planet formation. The scale of this system forces us to rethink how rare life really is. We once believed organic compounds were scarce, limited to special planets like Earth. Now we know they are as common as dust. They are everywhere, continuously produced, freely delivered to any world lucky enough to form. Earth is not an exception. It is the rule. Every planet in the galaxy receives the same gift from the universe, the building blocks of life, forged in interstellar factories, waiting for the right conditions to assemble into something alive. These products were delivered to Earth through an incredibly efficient transport system, one that has been operating for 4 billion years without rest or failure. A system we call comets. Every 76 years, Halley's Comet returns to Earth's skies. People rush outside to watch its long glowing tail, snap photos, marvel at its beauty. But few realize that what they are seeing is not just a pretty chunk of ice and rock. It is a time capsule, a traveling library carrying secrets from before the solar system was even born. Comets are cosmic freezers. They form on the distant edges of the solar system, where it is so cold that everything freezes and stays that way for billions of years. There is no heat from the sun to alter the materials. No atmosphere to oxidize them, no liquid water to dissolve them. Just extreme cold, preserving everything like a perfect cosmic safe. In 2014, Europe's Rosetta spacecraft caught up with Comet 67P after a 10-year journey through space. For the first time in history, humanity truly approached a comet, placed instruments on its surface, and analyzed what was hidden inside. What they found went far beyond expectations. 16 different amino acids, the basic building blocks of proteins. Not 1 or 2, but 16. Among them was glycine, the simplest amino acid, found in every protein in every living organism on Earth. This was not contamination from the spacecraft. These molecules were buried deep within the comet's core, preserved from before the solar system formed. Formamide was there too. This compound is critically important for creating nitrogenous bases, the letters that make up DNA and RNA. Without formamide, there is no easy pathway to assemble these components. Yet comets carry it with them, ready and waiting to be delivered to a planet somewhere. Most astonishing of all, scientists discovered molecular structures resembling primitive cell membranes. Fatty molecules that spontaneously organize into double layers, exactly the way real cell membranes are built. This was not random chaos. These structures showed order and organization, as if they were waiting to become the outer shell of a future cell. Comets do not just carry raw materials. They carry partially assembled components, biological starter kits that are almost ready to use. Place them in the right environment, with liquid water and energy, and they can quickly assemble into far more complex structures. The scale of this delivery system is hard to grasp. The Oort cloud, the farthest region of the solar system, contains trillions of comets. Trillions. Each one is a small capsule packed with biological material. They linger there, waiting for a gravitational disturbance, a passing star, a wandering giant planet. Then their orbits shift, and they fall inward, racing toward the planets. Over the past 4 billion years, Earth has been relentlessly bombarded by these comets. Especially during the early era known as the Late Heavy Bombardment, when millions of comets surged into the inner solar system, with dozens of impacts every single day. Each collision delivered tons, sometimes hundreds of tons, of organic material to the planet's surface. Every impact was a biological package. A fresh shipment of amino acids, sugars, lipids, complex molecules. Enough to test new combinations, new biochemical pathways. Earth did not have to invent life entirely from scratch. It received a constant supply from a cosmic warehouse. Paleontologists have noticed a strange pattern. Periods of intense comet activity often line up with sudden leaps in evolution. The late heavy bombardment 4 billion years ago coincides with the appearance of the first complex cells. Other comet showers throughout geological history are frequently followed by explosions of new species, biological innovations that are difficult to explain through slow, gradual evolution alone. Analysis of comet dust collected by NASA shows carbon, nitrogen, and sulfur isotope ratios similar to those found in Earth's living organisms. Not identical, but close enough to suggest a shared origin, or at least a vast exchange of material between comets and planets. Some comets may even contain liquid water inside their cores. The radioactive decay of heavy elements produces heat, enough to melt part of the internal ice and create small pockets of water. Inside these pockets, chemical reactions can continue slowly for millions of years as the comet drifts through interstellar space. They are like mobile laboratories, running biochemical experiments while wandering across the galaxy. When they finally collide with a planet, they do not just deliver simple molecules. They deliver the results of millions of years of research, compounds refined and filtered through countless cycles of freezing and thawing. This system works like Amazon for the universe. Except instead of 2-day delivery, it operates on a 2-million-year schedule. No signature required. No package inspection. Just impact, and the materials scatter across a planet's surface, ready for whatever can use them. The gravity of passing stars occasionally flings some comets completely out of the solar system, sending them into the space between stars. These travelers carry material from our solar system to others. In return, we also receive comets from distant systems. A vast network of biological material exchange spans the galaxy, operating for billions of years. In 2017, astronomers detected Oumuamua, the first object ever confirmed to have come from outside our solar system. With its strange shape and unusual trajectory, it passed through quickly before we could study it in detail. But it proved that interstellar visitors do reach us, possibly carrying material from worlds we have never seen. To be sure that the delivery actually works, direct evidence is needed. Not just comet chemistry, but proof that life itself can come from space, that it can exist on other planets. In 1976, we may have found that evidence. But NASA chose to stay silent. July 20, 1976 may have been the day human history changed. And then NASA chose silence. Viking 1 touched down on the blazing red surface of Mars after an 800 million kilometer journey. For the first time, humanity had placed a fully equipped laboratory on another planet. Its primary mission was simple, and extraordinarily bold, to search for life. One of the experiments Viking carried was designed by Dr. Gilbert Levin. He called it the labeled release experiment. The idea was brilliantly simple. Take a sample of Martian soil and mix it with a solution containing basic nutrients like sugars and amino acids. But these nutrients were tagged with radioactive carbon, a special form of carbon that can be easily detected. The logic was straightforward. If microorganisms existed in the soil, they would consume the nutrients. As they ate, they would metabolize and release carbon dioxide. And because the carbon in the food was radioactive, the CO2 they exhaled would be radioactive as well. Vikings' instruments could detect that gas without difficulty. Simple, elegant, hard to get wrong. Vikings scooped up a spoonful of Martian soil, placed it into the experiment chamber, added the nutrient solution, and waited. Within hours, the detector lit up. Radioactive carbon dioxide levels spiked sharply. The curve on the screen shot upward, exactly what you would expect when microorganisms suddenly begin feeding and metabolizing. The signal was strong, clear, unmistakable. The research team was stunned. They ran a control test. A second soil sample was heated to 160 degrees Celsius, hot enough to kill any known microorganism. Then they repeated the same procedure, added nutrients, and waited. This time, nothing happened. No radioactive carbon dioxide. The curve on the screen stayed flat and motionless. The sterilized sample produced no gas. The unsterilized sample did. This was precisely the result you would expect if there were living organisms in the Martian soil. Dr. Gilbert Levin was convinced he had found life. He wrote his report and prepared to announce the discovery. But NASA disagreed. Another instrument on Viking, designed to detect organic molecules, found nothing. It scanned the soil for organic carbon, the chemical fingerprints of living or once living organisms. There was nothing there. Not a single organic molecule. NASA called this a contradiction. How could life exist without any organic molecules to support it? No food, no remains, no waste. Just completely sterile soil. So the radioactive carbon dioxide in Levin's experiment must have come from some purely chemical reaction, not biology. Perhaps Martian soil contained a powerful oxidizing agent that reacted with water and released gas. For decades, this became the official explanation. The Viking experiment was a false positive. Mars was too cold, too dry, too irradiated to support life. The carbon dioxide came from chemistry, not biology. Case closed. But this explanation never fully satisfied skeptics. The pattern Viking recorded looked too biological. When Earth microbes are given fresh food, they respond quickly, feeding aggressively, metabolizing intensely. Then, as the food runs out, their activity gradually declines. Exactly the curve Viking observed, a sharp rise followed by a slow drop. Chemical reactions do not behave that way. They are steady and predictable. There is no phase of sudden feasting followed by fullness. They proceed at a fixed rate until the reactants are gone. The pattern Viking saw fits biology far better than chemistry. Now, decades later, we understand much more about life in extreme environments. We have found bacteria living in Antarctic ice, in acidic hot springs, in caves sealed off for millions of years. These places are no less hostile than Mars. If life can survive there, why not on the red planet? The problem with Viking's organic molecule detector was that it only scanned the surface. Ultraviolet radiation from the sun, barely filtered by Mars's thin atmosphere, blasts the ground directly. Cosmic rays penetrate constantly. This radiation is powerful enough to destroy organic molecules within weeks or months. The Martian surface is effectively sterilized by relentless radiation. But just a few meters below the surface, that radiation cannot reach. There, organic molecules can survive. There, microorganisms could live, shielded from the lethal rays above. Viking only scooped surface soil. It did not dig deeper. It did not look where life might be hiding. Dr. Gilbert Levin, the man who designed the experiment, remained convinced until his death in 2021 that he had detected life on Mars. He published dozens of papers, spoke at hundreds of conferences, and argued relentlessly that his results could not be explained by chemistry alone. Still, most of the scientific community remained skeptical. Now, with what we know about extremophiles, with evidence of liquid water beneath the Martian surface, with complex organic molecules being discovered by the Perseverance rover, scientists are starting to reconsider. Perhaps Levin was right all along. Perhaps in 1976, we truly did discover life on another planet. If that is true, the implications are staggering. It would mean we have had evidence of extraterrestrial life for nearly 50 years. It would mean Mars and Earth were both seeded by the same cosmic process. It would mean life is not rare or exceptional, but common throughout the solar system, perhaps even the galaxy. It would mean the idea that life comes from the cosmos is no longer a hypothesis, but a fact. And the strongest evidence for it may not be on Mars at all, but inside you, inside the genetic code shared by every living thing on Earth. What I'm about to tell you may be the clearest evidence yet of extraterrestrial design. It isn't on Mars. It isn't hidden inside a meteorite. It's inside every single cell of your body. Every living thing on Earth, from tiny bacteria visible only under a microscope, to blue whales weighing over 100 tons, to oak trees that have stood for centuries, to you watching this video right now, all use the same genetic code. Not almost the same. Exactly the same, down to every last detail. For letters, A, T, G, C, these are the four molecules that make up DNA, adenine, thymine, guanine, cytosine. They form long strings of millions, even billions of letters, creating the genome of every organism. But that's not the most important part. What matters is how those letters are read. They're read in groups of 3. Each group of 3 letters is a word, called a codon. There are 64 possible words, because 4 letters combined in groups of 3 gives 4 times 4 times 4 possibilities. Those words encode 20 amino acids, the 20 basic building blocks of all proteins. That means there are more words than amino acids. In other words, different words can mean the same thing. This is called redundancy, like having multiple ways to say the same idea in a language. Now here's where it gets strange. Every living organism on Earth uses exactly the same vocabulary. ATG always means methionine. GGC always means glycine. No exceptions. No dialects. No regional variations. Bacteria in the soil use the same dictionary as you do. Plants use the same dictionary as whales. Everything is identical. Think about what that really means. Imagine traveling across the entire world, from ancient Egypt, to China, to the Maya civilization in the Americas, to tribes in Africa, to the Inuit in the Arctic. And then discovering that every single one of them speaks the exact same language. Not similar languages. The same one. Same grammar, same vocabulary, same pronunciation. Every word means the same thing in every civilization. You would never believe that was a coincidence. You would know there had to be a common origin. Someone taught that language to everyone, or everyone descended from a single group. Mathematicians have calculated the odds of this happening by chance. There are millions of different ways to assign 64 3-letter words to 20 amino acids. Millions of possible genetic dictionaries. Yet all life on Earth uses the exact same one. The probability? About 1 in a million. Like flipping a coin 10,000 times in a row and getting heads every single time. And that's still not the craziest part. When scientists ran computer simulations, testing millions of different genetic codes, they found something astonishing. The code used on Earth isn't just one of many workable options. It ranks in the top fraction of a % of all possible codes. What does best mean here? It means optimized to minimize damage from mutations. DNA is constantly under attack, from radiation, from chemicals, from copying errors. Sometimes one letter changes into another. A becomes G, T becomes C. Errors like that can be deadly for a cell. But Earth's genetic code is designed so that when a letter changes, the new word often still encodes the same amino acid, or at least a very similar one. It's like misspelling a word but the reader still understands what you meant. Error correction is built directly into the language. On top of that, this code compresses information with incredible efficiency. Like a perfectly optimized zip file, it packs the maximum amount of information into the smallest possible space. Each gene doesn't just encode a protein, it also contains instructions for when that gene should turn on, for how long, and at what intensity. Everything is tightly packed, without wasting a single bit. How could a system like this evolve by chance? How could nature test millions of different codes and just happen to land on one of the very best, when a merely good enough code would have been sufficient for life to exist? It's like randomly smashing keys on a keyboard and accidentally producing a computer program that not only runs flawlessly, but is more optimized than anything professional programmers have ever written. Not impossible, but so unlikely it borders on unbelievable. And then there are the recent discoveries, the ones that make you rethink everything. Scientists have begun analyzing DNA at a deeper level, not just looking at how it encodes proteins, but at the hidden mathematical patterns embedded within it. What they found surprised even the most skeptical researchers. The Fibonacci sequence. You know it, the sequence where each number is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13. It appears all over nature, from the spirals of seashells to the way petals arrange themselves on flowers. It also appears in DNA, in the way molecules twist around each other, in the spacing between the spirals. Prime numbers. 2, 3, 5, 7, 11. Numbers divisible only by 1 and themselves. They show up in the lengths of certain genes, in the repeating cycles of some DNA sequences. Not everywhere, but far more often than randomness would allow. Even the constant pi, the ratio of a circle's circumference to its diameter, 3.14. Some researchers claim to have found pi encoded in specific DNA sequences, in the way molecules arrange themselves according to precise mathematical ratios. These aren't vague patterns you can find if you stare long enough at any dataset. These are exact mathematical structures, appearing in places where they serve no functional purpose. They don't help DNA work better. They don't make proteins more stable. They're just there. Like a signature. Like a hidden message. Some scientists call them wow signals hidden in the genome. Like the famous wow radio signal detected by astronomers in 1977, these patterns are too precise, too improbable to be random. They feel like someone trying to say, hey, I'm here. I designed this. Someone designed the genetic code. Not random evolution. Not natural selection. But an intelligence that understood both biology and mathematics at a level we're only beginning to grasp. An intelligence that wanted to leave a trace, wanted those smart enough to read the code to realize they are not alone, that they are part of something far bigger. Earth was prepared for life. The genetic code was designed. Organisms were delivered by meteorites and comets. But the greatest preparation, the most fundamental transformation that turned Earth from a dead world into a living planet, happened 2.5 billion years ago. 2.5 billion years ago, the impossible happened. A transformation that, by every calculation of modern science, should not have been able to occur within that span of time. Earth's atmosphere back then was nothing like it is today. There was no oxygen. Not even 1%. Instead, it was filled with methane, ammonia, carbon dioxide, gases that are toxic to most life today. The sky glowed orange-red instead of blue. If you had stood on the surface of Earth at that time, you would have suffocated within seconds. Then everything changed. Within 500 million years, a period that sounds long but is actually incredibly short in geological terms, atmospheric oxygen rose from 0 to 21%. 21%. Exactly the same as today. The change was so fast that it triggered the first mass extinction in Earth's history. Millions of species that could not tolerate oxygen, a substance that was poison to them, were wiped out. Science explains this event through cyanobacteria, simple microbes capable of photosynthesis. They absorbed sunlight, pulled carbon dioxide from the air, and released oxygen. As more and more of them reproduced, more oxygen accumulated, until the entire atmosphere was transformed. Sounds reasonable, right? But when scientists ran computer simulations, they ran into a serious problem. For cyanobacteria to produce enough oxygen to reach 21% of the atmosphere in 500 million years, they would have had to reproduce at a rate 20 times faster than anything ever observed in nature. They would have needed to cover every water surface on Earth, from the oceans down to the smallest puddles. They would have had to operate continuously, without rest, without disease, without being eaten by other organisms, for 500 million years. Even if all those conditions were met perfectly, simulations show the process should have taken at least 10 billion years. 10 billion. Twice the age of Earth. 3 times longer than life has existed on this planet. The math does not work. There simply is not enough time. And there is more. Photosynthesis is not a simple process. It is one of the most complex biological mechanisms ever discovered. It requires 2 separate photosystems, known as photosystem 1 and photosystem 2, working in perfect synchronization, like 2 gears locked together. Each system contains hundreds of complex protein molecules, arranged in precise 3-dimensional structures. At the center are chlorophyll molecules, antennas that capture light. Surrounding them are chains of electron transport molecules that convert light energy into chemical energy the cell can use. The entire system must operate with nanosecond precision. One small error, and the whole process collapses. How could something this complex evolve? Traditional theory says it developed gradually, step by step, over millions of generations. Each small improvement provided a survival advantage, favored by natural selection. But the problem is that photosynthesis only works when the entire system is complete. Half a system does nothing. It is like having a car engine without wheels, brakes, or a steering wheel. It does not move, it provides no advantage, and natural selection has nothing to favor. When scientists examined the earliest cyanobacteria fossils, they found photosynthesis fully formed from the very beginning. There were no transitional stages with simpler photosystems. No evidence of gradual development. It simply appeared, fully functional, ready to go. It is like digging through a Stone Age archaeological site, finding crude stone tools, and then suddenly, in a slightly newer layer, discovering a computer chip. No intermediate steps. No signs of technological progression. Just rough stone, and then modern technology. Isotope analysis of rock layers from the Great Oxidation Event reveals something else equally strange. The ratios of carbon, sulfur, and iron isotopes do not match what we would expect from purely Earth-based biological processes. They carry chemical signatures suggesting the involvement of organisms using metabolic pathways unlike anything found on Earth today. On top of that, the Great Oxidation Event coincides with a spike in meteorite bombardment. Analysis of impact craters from that era shows a sudden increase in extraterrestrial material reaching Earth. Almost as if someone was deliberately delivering extra material to the planet at exactly the right moment. There is another explanation for the Great Oxidation Event, one that many scientists are reluctant to say out loud. Cyanobacteria did not evolve on Earth. They were sent here, fully formed, tested across thousands of other worlds. They were specifically designed to terraform an atmosphere, turning a dead planet into one capable of supporting complex life. This was not random seeding. It was purposeful, planned planetary engineering. Someone looked at Earth 3 billion years ago and saw a world with liquid water, plenty of sunlight, but no oxygen to support complex organisms. They decided to fix that. They sent cyanobacteria, perhaps via meteorites, perhaps via comets. These microbes were genetically programmed to reproduce rapidly, to withstand extreme conditions, to survive in environments toxic to most other life. Their mission was simple: convert carbon dioxide into oxygen. Do it for hundreds of millions of years. Prepare the planet for what comes next. The plan worked perfectly. In 500 million years, not the 10 billion predicted by simulations, the atmosphere was fully transformed. Oxygen reached 21%, enough to support complex animals with circulatory systems, respiratory systems, and large brains. The next phase of the project could begin. Cyanobacteria did not randomly evolve on Earth. They were tools of planetary engineering. The first step in a long-term plan to turn a dead world into a living one. They were the delivery system for what would come later, more complex organisms that require oxygen to breathe. That delivery system is still running today. It is in the soil, in the water, in the air you are breathing right now. Tiny, invisible, yet capable of reshaping an entire planet's biosphere. While you are watching this video, millions of viruses are rewriting your DNA. No, this is not bad news. It might be the way life from the cosmos keeps updating and upgrading living beings on Earth. 8% of your genome is viral DNA. Not active disease-causing viruses, but genetic fragments from viruses that infected our ancestors millions of years ago, became permanently integrated into their genomes, and were passed down from generation to generation. 8%. That means roughly 1 out of every 12 pieces of DNA in your body came from a virus. We usually think of viruses as enemies, as agents of disease that must be destroyed. But that may be the wrong way to see them. Maybe viruses are not invaders, but genetic engineers. Not malware, but software updates. Viruses can do something ordinary organisms cannot. They can move genes between completely unrelated species. A virus can infect a bacterium and pick up a piece of its genetic code. That same virus can then infect a plant and insert that bacterial gene. Later, it can jump into an animal, carrying a hybrid genetic package from both bacteria and plants. This kind of horizontal gene transfer cannot happen through normal reproduction. You cannot breed a bacterium with a blade of grass. But viruses can. They act as genetic bridges between distant forms of life, allowing information to flow in ways standard evolution could never achieve. Viruses are incredibly tough. They have been found in the stratosphere, 25 miles above Earth, where conditions resemble outer space. They live at the bottom of the ocean under crushing pressure. They have been discovered in Antarctic ice, frozen for hundreds of thousands of years, still intact and still capable of infection once thawed. Their structure is astonishingly simple, just a protein shell wrapped around a strand of DNA or RNA. No cells, no organs, no metabolism. And because they are so simple, they are almost impossible to destroy. Radiation can damage their genetic material, but not erase their structure. Extreme temperatures barely affect the protein shell. The vacuum of space does not kill them, because they were never truly alive in the traditional sense. When scientists analyze different kinds of viruses, something strange appears. Many viruses carry genes that do not match any known organism on Earth. These so-called orphan genes do not appear in genetic databases compiled from millions of sequenced species. So where did they come from? Some of these genes encode proteins that help survive extreme environments, high radiation, extreme cold, immense pressure. Yet the viruses carrying these genes often infect organisms that live in mild, ordinary conditions. Why would they need genes for environments they never encounter? Unless those genes did not originate on Earth. Unless they are relics from other worlds, from far harsher environments. Viruses could be biological memory banks, storing genetic information from extinct biospheres, from dead planets. They drift through space, arrive on Earth, and slowly release that information into new life. Every time a virus infects a cell, it has a chance to insert a new piece of genetic code into the host genome. Most of the time, this does nothing, or even causes harm. But occasionally, a new gene provides an advantage. It helps an organism resist disease. It allows survival in harsher conditions. It enables entirely new abilities. 8% of the human genome is viral. But it is not useless junk. Some viral DNA sequences play critical roles. They help regulate the immune system. They are involved in embryonic development. They contribute to brain function. Viruses did not just infect us. They became part of us. Now add the role of tardigrades. These tiny creatures are not only capable of surviving in space. They also travel with passengers. Viruses cling to their surfaces. Bacteria live in their guts. When tardigrades journey, they carry entire microscopic ecosystems with them. 20% of tardigrade genes have no clear origin. They do not match any other known organism on Earth. Analysis suggests these genes may come from bacteria, from viruses, from other organisms the tardigrade encountered in the distant past. Tardigrades collect genes not only from their ancestors, but from everything they meet. They are like biological cargo trucks, hauling genetic material from place to place. When a tardigrade lands on a new planet, it does not arrive alone. It brings viruses, bacteria, and strange DNA fragments gathered over millions of years of travel. All of it preserved in the tardigrade's frozen state, waiting for the right conditions to wake up. When scientists study tardigrades from different environments, they find each population carries a different microbial community. Antarctic tardigrades host cold-adapted bacteria. Desert tardigrades carry drought-tolerant microbes. Tardigrades from hot springs harbor heat-loving bacteria. Each group is a living collection shaped by its local environment. Now imagine a tardigrade from another planet, drifting through space for millions of years, finally reaching Earth. It carries viruses and bacteria from its home world. These organisms contain genes unlike anything found here. When they begin infecting Earth life, they insert new genes, new abilities, biological designs tested on other worlds. This is not an infection. It is a software upgrade. A biological operating system update. It is how genetic information spreads across the galaxy, not through radio signals, but through tiny, resilient, patient biological couriers. This system is still running. Every day, new viruses fall from the stratosphere. Every year, meteorites deliver microorganisms from space. Every century, new comets drop off their biological cargo. Earth is not a closed system. It is a node in a vast galactic network of genetic exchange. Sometimes these couriers literally fall from the sky. Not as a metaphor, but in the most literal sense. They rain down from above, carrying passengers that, when you see them under a microscope, make you wonder whether they truly belong to this Earth at all. On July 25, 2001, the sky over India began to bleed. In Kerala, in southern India, people woke up that morning to a scene straight out of a horror movie. Dark red raindrops fell from the sky, soaking clothes hanging in courtyards, staining rooftops, pooling on the streets like blood. Panic spread quickly. Some thought of ancient prophecies and the end of the world. Others ran to churches and temples to pray. But the rain did not stop. It continued for nearly 2 months, scattered across an area of more than 100 square miles. Sometimes it came down hard, sometimes as a light drizzle. But it was always red. Always leaving behind those strange stains. The stains were almost impossible to remove. People tried soap, strong detergents, even diluted acids, but the red color clung stubbornly. Clothes had to be thrown away. Walls had to be repainted. Whatever was in this rain was not ordinary dirt. The Indian government quickly offered an explanation. It was just dust from the Arabian desert, they said, carried by winds across the Arabian Sea and washed down over Kerala by rain. Nothing to worry about. A rare but natural weather phenomenon. Some scientists were not convinced. They collected rainwater samples and brought them into the lab. Under the microscope, they saw something that stopped them cold. The rainwater was filled with countless tiny cells, about 4 micrometers across, roughly half the size of a typical bacterium. The cells were deep red, which explained the color of the rain. They had thick cell walls and complex internal structures. By appearance alone, they looked alive. But when scientists tried to analyze them more closely, things became strange. The cells contained no DNA. No RNA either. These are the two molecules every known life form on Earth uses to store genetic information, to reproduce, to run metabolism. No DNA. No RNA. Only unfamiliar molecules that no one had seen before. By Earth's scientific definition of life, these cells should not exist. Every organism, from bacteria to humans, relies on DNA or RNA. No exceptions. Until now. Scientists tried to grow the cells in different nutrient media. Media for bacteria. Media for fungi. Media for algae. Nothing worked. The red cells refused to grow in any environment where Earth life normally thrives. They just sat there, not dying, but not reproducing either. And yet, they showed extraordinary abilities. Exposed to extreme heat, up to 300 degrees Celsius, they did not die. Blasted with intense ultraviolet radiation, enough to kill most bacteria in seconds, they remained intact. Completely dried out, stripped of all water and stored for months, they could come back to life when water was added again. Their method of reproduction was just as odd. Instead of splitting like ordinary bacteria, they reproduced by budding. A small outgrowth formed on the parent cell, grew larger, then detached as an independent cell. More like yeast than bacteria. Dr. Godfrey Lewis of Mahatma Gandhi University spent years studying these cells. He reached a bold conclusion. These were not Earth organisms. They came from space. Carbon isotope analysis showed ratios unlike anything found in terrestrial life. Their chemical signature suggested formation in an environment very different from our solar system, possibly around another star, with different isotope abundances and different physical conditions. Timing made the mystery even deeper. Many of the red rain events happened shortly after people reported strange lights in the sky. Bright fireballs streaking overhead, leaving smoke trails, exploding in midair. Like small meteors burning up in the atmosphere. But no fragments were ever found. Only red rain, falling hours later. Dr. Lewis proposed that these were not ordinary rocks. They were biological capsules, packed with living cells, breaking apart high in the atmosphere and scattering millions of cells down to Earth with the rain. Cells that had traveled through space, possibly for millions of years, waiting to land on a planet with liquid water. Kerala was not alone. Historical records describe hundreds of red rain events around the world. In 2003, Colombia experienced similar red rain. In 2012, Sri Lanka. In 2014, Austria. Each time, strange cells were found in the water. When cells from different locations were compared, they looked remarkably alike, despite being separated by thousands of kilometers. As if they all came from the same source, distributed globally through different meteor events. Mainstream science remains skeptical. Researchers argue that far more evidence is needed. Deeper genetic analysis, even though these cells lack DNA in the usual sense. More work on their true origin. But it is hard to deny that something unresolved is happening here. Each red rain event could represent millions, perhaps billions, of organisms from space delivered to Earth. Falling from the sky, seeping into soil, flowing into rivers, lakes, and oceans. Some may die. But some may survive, find the right conditions, begin to reproduce, and quietly blend into Earth's biosphere. And this process may not be limited to 2001. It may have been happening throughout Earth's 4 billion year history. Every century, every millennium, new shipments arriving from space, carrying new biological designs, new genes, new capabilities. Earth may not be a closed system evolving in isolation, but part of a vast biological exchange network stretching across the galaxy. The Kerala blood rain may simply be one rare moment when we actually noticed. How many similar events have happened without anyone paying attention, because the rain was not bright red? How many cosmic organisms might be living in the soil, the water, the air around us, completely undetected? All of this evidence, from meteorites carrying amino acids, to near-immortal tardigrades, to viruses with unfamiliar genes, to red rain filled with cells that have no DNA, all of it points toward a much bigger question. A question that, once you truly sit with it, completely changes how you see humanity's place in the universe. In 1950, physicist Enrico Fermi was sitting down to lunch with his colleagues at Los Alamos. They were chatting about recent reports of flying saucers, about the possibility of interstellar travel. Then, suddenly, Fermi asked a simple question: where is everybody? It sounded casual, almost offhand. But hidden inside that question was a profound paradox, a mystery that, nearly 100 years later, we still don't have a satisfying answer to. Our Milky Way contains 400 billion stars. 400 billion, a number so vast the human mind can barely grasp it. If you counted one star every second, it would take 12,000 years to finish. Among them, scientists estimate there are at least 100 billion rocky planets, roughly Earth-sized, orbiting in zones where liquid water could exist. 100 billion potential homes for life, in our galaxy alone. And the universe contains more than 2 trillion galaxies. Do the simple math, and you end up with a number of potentially habitable planets greater than all the grains of sand on every beach on Earth. The universe was born 13.8 billion years ago. Earth is only 4.5 billion years old. That means there were 9 billion years before our planet even formed. 9 billion years for civilizations to emerge, to evolve, to spread across the galaxy. Humanity took just 10,000 years to go from farming societies to space rockets. Give a civilization 1 million years, 10 million years, 1 billion years, what could they become? By all logical calculations, the galaxy should be overflowing with signs of intelligent life. We should be detecting radio signals from thousands of civilizations. We should see evidence of massive engineering projects, structures built around stars to harvest their energy. We should see automated probes visiting the solar system. We should see something. But after 70 years of searching, we see nothing. No clear radio signals. No artificial structures. No alien spacecraft. Just silence. The terrifying silence of a galaxy that appears completely empty. This is the Fermi paradox. If extraterrestrial civilizations exist, with so many stars and so much time, why don't we see them? Where are they? The traditional explanations are all frightening in their own way. Maybe every civilization destroys itself before it can achieve interstellar travel. Nuclear weapons, biological warfare, environmental collapse, or other dangerous technologies may always wipe them out before they leave their home world. This is the idea of the Great Filter, that there is some barrier no one can pass. Maybe intelligence is far rarer than we think. Maybe life itself is common, but intelligent life capable of building technology is extraordinarily rare. Maybe, in the entire Milky Way, it's just us. Truly alone in a universe vast beyond comprehension. The most unsettling explanation is the dark forest hypothesis. The galaxy is full of civilizations, but everyone stays silent out of fear. One or more extremely powerful civilizations actively destroy anyone who broadcasts their presence. The galaxy is like a dark forest, everyone hiding, afraid to make a sound, terrified of being noticed by a predator. All of these explanations have problems. But there is another one, an explanation that, once you understand it, completely changes how you see yourself. We don't find aliens because we are them. Billions of years ago, when the Milky Way was young, the first civilizations emerged around early generation stars. They grew, built empires spanning hundreds of star systems. They reached levels of technology we can barely imagine. They lived for millions, tens of millions of years. Then they confronted a brutal truth of physics. Their stars aged. Nuclear fuel ran out. Light dimmed, then faded away, or worse, exploded into supernovae, incinerating everything. There was no escape. You can't move an entire civilization to another star. Too far, too slow, too many people. They faced a choice. Accept extinction, or find another way to survive. They chose the second option. But not through spaceships. Through biology. They encoded their entire legacy into DNA. Genetic codes optimized to resist radiation. Biological designs refined through billions of years of evolution. Mathematical patterns hidden like signatures. They created ultra-resilient organisms, capable of surviving space, deep ice, the harshest environments imaginable. Then they sent billions of biological capsules to thousands of promising planets. Earth was one of them. The first capsules arrived here 4 billion years ago. They carried bacteria, viruses, maybe even tardigrades. They carried a universal genetic code. Blueprints for photosynthesis, for nervous systems, for eyes, for brains. All compressed into tiny packets of biological information. These organisms did not evolve on their own from simple chemistry. They inherited billions of years of research and development from civilizations long gone. They carried the legacy of worlds that no longer exist. They were intelligence's way of surviving the death of stars. Over 4 billion years, those designs were slowly deployed. The Cambrian explosion wasn't random evolution, it was the activation of pre-written blueprints. The emergence of humans wasn't a lucky accident, it was the final target of the project. We are not a product of Earth alone, but of the galaxy. We carry the DNA of ancient civilizations in every cell. We are slowly rebuilding the technology our cosmic ancestors once had. We begin searching for extraterrestrials, not realizing we are searching for ourselves, for civilizations that sacrificed everything to create us. The silence of the galaxy is not a failure. It is a stunning success. The seeding project worked so well that its product, us, is now developing technology, looking up at the sky, wondering if anyone else is out there. Not realizing that anyone else is our own ancestry, encoded in our genes, waiting for us to become intelligent enough to read the message. And this idea is supported by someone you wouldn't expect. A Nobel Prize winner, one of the greatest scientists of the 20th century. Someone whose words made the entire world stop and listen. Francis Crick was one of the greatest scientists of the 20th century. In 1953, together with James Watson, he discovered the double helix structure of DNA, a breakthrough that completely transformed modern biology. They received the Nobel Prize for this work. Crick spent much of his life studying DNA, understanding its complexity better than almost anyone else, how it works, and what it takes to create a living organism. In 1973, Crick published a scientific paper that stunned the entire scientific community. He called his theory directed panspermia. He argued that life on Earth is far too complex to have evolved naturally within the time available. Instead, he proposed that advanced extraterrestrial civilizations deliberately sent genetic material to Earth aboard unmanned spacecraft. This was not an amateur or a conspiracy theorist speaking. This was a Nobel laureate, someone who understood DNA more deeply than nearly anyone on the planet. When Crick said something, people had to listen. Crick's argument was built on cold, unforgiving mathematics. He calculated the probability of even the simplest bacterial cell assembling itself from random molecules. A single bacterial cell contains roughly 4 million different components, each one needing to be arranged precisely, all of them working together in perfect coordination. DNA must have exactly the right sequence. Proteins must fold into the correct shapes. The cell membrane must form the right structure. The chance of all of this happening at once by pure accident. Crick calculated a number so small it is almost horrifying. Astronomer Fred Hoyle, who supported Crick, compared it to the probability that a tornado sweeping through a junkyard would accidentally assemble a fully functional Boeing 747. In reality, the odds are far smaller than that. The actual number they proposed was 1 in 10 to the power of 40,000. To put that in perspective, the total number of atoms in the observable universe is only around 10 to the power of 80. The probability of a cell assembling itself is vastly smaller than randomly picking one specific atom out of the entire universe, then doing it again hundreds of times, choosing the exact same atom every single time. Even with all the time from Earth's formation until now, even with trillions upon trillions of molecular interactions every second, the probability remains essentially zero. The math does not work. There is not enough time. This is why Crick concluded that life could not have arisen naturally on Earth. His solution? Life came from elsewhere, from a civilization that had billions of years to solve this problem. They did not leave life to chance. They designed it. They encoded it into DNA. They created simple but resilient organisms capable of surviving the vacuum of space. Then they sent millions, even billions, of these biological capsules to promising planets across the galaxy. Some of Crick's colleagues thought he had lost his mind. A Nobel Prize winner talking about aliens seeding life? This had to be a joke. But Crick was completely serious. He published more papers, presented at conferences, and argued his case with mathematics, biology, and logic. What is remarkable is that now, more than 50 years later, Crick's theory no longer sounds as crazy as it once did. Because we are beginning to develop exactly the technologies he described. Modern scientists have learned how to encode information into DNA. In 2017, researchers encoded an entire movie into the DNA of bacteria. In 2020, they stored hundreds of terabytes of data in synthetic DNA. DNA can hold more information than any storage device humans have ever created, and remain stable for thousands of years. We are designing organisms for space. Biotechnology companies are engineering bacteria that can survive extreme conditions, producing fuel, food, and medicine in airless environments. NASA is studying how microorganisms could be used to terraform Mars, transforming a toxic atmosphere into something breathable. We are building self-replicating molecular machines, nanorobots that can create copies of themselves using raw materials from their surroundings. Combine this technology with engineered DNA, and you get exactly what Crick described, biological capsules that can survive space, replicate upon reaching a new planet, and begin seeding life. We have accomplished all of this in just a few decades of biotechnology research. We only began to understand DNA in the 1950s. Now, less than a century later, we can edit genes, create new organisms, and encode information into DNA. We are moving fast. What could a civilization a million years ahead of us do? They would refine these technologies beyond anything we can imagine. They could design entire biospheres, encode them into tiny organisms, and send them across the galaxy. They could create seeds of life containing billions of years of evolution, ready to deploy on any suitable planet. Recent discoveries make Crick's theory even more compelling. In 2017, astronomers detected Oumuamua, the first object ever confirmed to have entered our solar system from another star system. Its shape was extremely unusual, long and thin like a cigar, with proportions no natural asteroid had ever shown. Its trajectory was strange as well. As Oumuamua passed through the solar system, it accelerated in a way gravity could not explain, as if something were pushing it. Some scientists, including Harvard astrophysicist Avi Loeb, suggested that Oumuamua might be a probe from another civilization, a light sail pushed by radiation pressure from the sun. The idea sparked intense controversy. Many scientists strongly disagreed. But no one could fully explain Oumuamua's strange properties using natural theories alone. It is now gone, far too distant for further study. But it left behind a question: how many similar objects have passed through our solar system without us ever noticing? Crick died in 2004, never seeing Oumuamua. But he had predicted exactly this kind of object: unmanned spacecraft carrying genetic material, traveling between the stars. Maybe Oumuamua was not a vessel filled with living organisms. But perhaps others were, millions of them, arriving at Earth over the past 4 billion years. Perhaps some of them delivered their cargo. Is any of this true? Where do we fit into this grand story? Are we the product of an ancient seeding project? The descendants of long-dead civilizations? Or simply a random accident on a lucky planet? The answer may lie within you, in the genetic code you carry, and in the hidden possibilities humanity is only beginning to uncover. If everything we have discovered is true, then you are not human in the way you've always thought. You are something far greater, far older, far more extraordinary. Look at your hands. Every cell in them, every strand of DNA, carries a blueprint designed billions of years before our solar system even existed. These blueprints were not drawn on Earth. They were created on distant worlds, orbiting stars that died long ago. They were tested on thousands of other planets, refined through billions of years of real evolution, across many worlds, under countless conditions. The genetic code inside your body is not the product of 4 billion years of evolution on Earth. It is the result of 10 billion, maybe 15 billion years of biological experimentation across the galaxy. You are not version 1.0 of life. You are version 10.0, upgraded, optimized, perfected through endless generations on endless worlds. You were optimized to survive space travel. That is why your genetic code has such sophisticated error correction mechanisms. That is why it resists radiation better than any random design should. That is why it contains redundancy, backups, and recovery systems that scientists are still struggling to fully understand. Your ancestors were not just apes in Africa 3 million years ago, or at least not only them. Your true ancestors were ancient civilizations on planets we will never see, intelligent beings who reached the peak of their evolution and then faced the unavoidable death of their stars. They did not run. They did not build generation ships to flee to another star. Instead, they did something far wiser. They encoded themselves into DNA. They turned their legacy into biological information. They sacrificed their bodies but preserved their intelligence, their knowledge, their essence inside tiny biological capsules capable of surviving the vacuum of space. You are not a random accident. You are the product of the greatest engineering project in galactic history, a project that lasted billions of years, spanned millions of light years, and involved countless civilizations that sacrificed themselves to ensure that intelligence would never truly go extinct. Every time you look up at the night sky and feel a longing to know what's out there, that isn't just curiosity. It is an ancient instinct carved deep into your genes, a call from your cosmic ancestors, reminding you that you belong to the stars, not just this planet. Why does humanity crave space exploration? While most animals on Earth care only about finding food, reproducing, and surviving, humans look up, build telescopes, launch rockets. Why? Because it is a mission encoded into our DNA. We are meant to explore. We are meant to expand. We are meant to find a way to survive beyond a single planet. Why do we search for life beyond Earth? Why spend billions of dollars building massive telescopes and sending probes to distant worlds? Not for profit. Not for resources. But because of a deep, almost unexplainable yearning. We are searching for family. We are searching for proof that we are not alone, that there are others like us out there. Why do we want to spread beyond Earth? Why talk about terraforming Mars, building colonies on the Moon, sending humans to the stars, even while Earth still has so many unsolved problems? Because this is not a choice. It is an order written into our genetic code billions of years ago. Our genes know that living on a single planet is suicide. One asteroid, one catastrophe, one dying star, and everything ends. We must spread, just as our cosmic ancestors once did. Now we are approaching the point where we can continue that mission. We have learned how to read DNA. We are learning how to write it. In the coming decades, we will be able to modify humans to live in space, to endure higher radiation, to live far longer, to adapt to environments our current bodies cannot survive. We will become the next seeders. Just as our ancient ancestors sent life to Earth, we will send it to Mars, to the moons of Jupiter and Saturn, and perhaps even to planets around nearby stars. We will not only explore. We will terraform. We will turn dead worlds into living ones, just as Earth was once transformed for us. This is not meaningless ambition. This is destiny, our role in a story far larger than ourselves. We are the next link in the chain of cosmic civilizations. Those who came before us completed their task. Now it is our turn. The Fermi paradox is no longer a paradox once you understand this. We are not searching for aliens. We are searching for relatives. Other worlds in the galaxy were seeded by the same project that created us. They may be thousands of light years away, but they carry the same ancestral DNA, the same legacy, the same mission. One day, when we meet them, we will not encounter strangers. We will meet long-lost siblings, other children of the same ancient parents. We will recognize each other not by outward appearance, but by the genetic code within, by the same mathematical patterns etched into DNA, by the same hunger to explore, expand, and endure. This is the true meaning of being human. Not merely a lucky animal on a small planet, but the heir to a legacy that spans the galaxy, the guardian of an intellectual flame lit by ancient civilizations billions of years ago, and the one responsible for carrying that flame forward, to untouched worlds and unborn futures. But all of this remains theory, speculation, unless we have modern evidence unfolding right now, proving that cosmic seeding is not just a distant past, but an ongoing process, still active, still sending new messages to Earth today. While we argue over theories, over things that might have happened billions of years ago, our robots on Mars are finding something astonishing. The evidence is not locked in a distant past. It is unfolding right now. In February 2021, the Perseverance rover touched down inside Jezero crater on Mars. Its mission was to search for signs of ancient life. What it found went far beyond expectations. Perseverance drilled into rocks, collecting samples from different geological layers. The analysis revealed complex organic molecules, identical to those found in the earliest fossils on Earth. Not just similar, identical. The same structures, the same arrangements, the same chemical signatures. But here is the truly remarkable part. Some of these molecules are not entirely ancient. Isotopic analysis shows signs of relatively recent activity, possibly within the last few million years, maybe even more recent. On Mars, a planet we believed had been completely dead for billions of years, something is still happening. The structure of these molecules cannot be explained by geology alone. They display features that only living systems are known to produce. Precise atomic arrangements, fragile chemical bonds that exist only in biological environments, isotopic ratios shifted away from natural equilibrium in ways that only metabolism can create. The implications are profound. Mars and Earth both contain the same organic molecules. Both show traces of life, or at least the precursors to life. This cannot be a coincidence. These two planets must share a common biological origin. Both were targets of the same cosmic seeding process. Mars and Earth, neighboring planets in the same solar system, have both been receiving biological deliveries from space for the past 4 billion years. Earth was luckier. It retained liquid water and a thick atmosphere, allowing life to flourish. Mars lost its atmosphere and became dry and cold, but life may still be hiding beneath the surface, waiting for better conditions. Perseverance is not the only source of evidence. The James Webb Space Telescope is observing clouds of gas around stars hundreds of light-years away. It is detecting complex organic compounds throughout the galaxy. Molecules we once believed could form only under Earth-like conditions are now being found in the coldest, most distant regions of space. Amino acids drift through interstellar clouds. Sugars appear in star-forming regions. Even structures resembling cell membranes show up in spectral analyses of distant nebulae. The building blocks of life are not rare. They are as common as cosmic dust. The Europa Clipper spacecraft launched in 2024 and will reach Europa in 2030. Its mission is to study the ocean hidden beneath 15 miles of ice. This ocean is twice the size of all Earth's oceans combined. It has existed for billions of years, kept warm by tidal forces from the giant planet Jupiter. Preliminary analysis of water plumes erupting from Europa's surface has already detected organic compounds, possibly even amino acids. Europa's water shows isotopic signatures eerily similar to Earth's, as if both worlds drew their water from the same cosmic source. Europa Clipper will fly directly through these plumes, collecting samples firsthand. We may be on the verge of discovering signs of extraterrestrial life within our own solar system. Even right here in Earth orbit, we are finding strange things. Astronauts aboard the International Space Station have collected microorganisms from the stratosphere, 25 miles above Earth's surface. Some of these microbes do not match any known species in our databases. Their DNA is unusual, unlike anything we recognize. Where did they come from? Were they lifted from Earth by winds, or did they fall from space? Experiments on the space station reveal even more surprises. Some bacteria, when exposed to space, not only survive but grow faster than they do on Earth. They reproduce more quickly, show heightened metabolism, and even develop new abilities they do not display under normal conditions. It is as if the space environment is activating dormant genes within their DNA. Genes seemingly pre-programmed for cosmic conditions, lying silent for millions of years, suddenly awaken when the environment is right. This is not ordinary evolution. Evolution does not produce traits for environments an organism never encounters, unless those organisms once lived in space, or were designed to do so. Every year, we uncover more evidence. New meteorites fall carrying fresh organic compounds. Deeper analysis of old samples reveals details we previously missed. Advancing technology allows us to see farther, deeper, and with greater precision. The picture grows clearer by the day. Panspermia is not a theory about the distant past. It is a process happening right now. Every day, 100 tons of cosmic material fall onto Earth. How much of it carries living microorganisms? How much brings new genes, new biological designs, new capabilities? We fail to notice because they are too small, too numerous, too common. Like fish unaware of the water they swim in, we do not realize we are living within a constant flow of biological material from space. Earth is not a closed system. It is a node in a vast galactic biological network, constantly receiving, constantly sending, constantly exchanging. The evidence is not hidden in ancient books or billion-year-old fossils. It is orbiting Mars, sampling Europa, analyzing the light of distant stars. The evidence is already in the hands of scientists today, waiting to be decoded, understood, and revealed. The question is no longer, did life come from space, but rather, what will we do with this knowledge? When we understand that we are part of a much larger story, that we carry the responsibility of continuing a mission begun by civilizations long gone, how will we choose to act? Now let's talk about the numbers. Because when you look at pure mathematics, the panspermia strategy is not just possible. It is the only rational way a civilization can ensure its survival beyond the death of its star. Compare the two strategies. The first is building generation ships to carry humans to other stars. It sounds heroic, doesn't it? But look at the real cost. A spacecraft capable of carrying 1,000 people would need a fully closed biological system, power generation that works for thousands of years, and engines powerful enough to reach 1/10 the speed of light. The cost of building such a ship would equal the combined GDP of an entire civilization over centuries. The chance of success is terrifyingly low. One small accident, one technical failure, and the entire crew dies in the void. Travel time to the nearest star would be hundreds, maybe thousands of years. During that time, the crew would have to maintain a stable society with no wars, no pandemics, no internal collapse. Human history suggests this is almost impossible. Now compare that with panspermia. The cost is nearly zero. You do not need massive spacecraft. All you need are tiny biological capsules, each no larger than a grain of sand. Every capsule contains engineered microbes, encoded with all the information needed to rebuild complex life. With the resources required to build one crude starship, you could create billions of biological capsules. Billions. You send them in every direction, toward every star within hundreds of light years. Even if 99% fail, you still have millions reaching their destinations. Let's do a simple calculation. Send 100 capsules to each star system within 1,000 light years. There are roughly 1,000 star systems in that range. 100 times 1,000 is 100,000 capsules. 100,000 chances for life to take hold on a new world. Assume only 1% succeed. Just 1% of the capsules land on planets with liquid water, sunlight, and long-term stability. That is 1,000 living planets. 1,000, from a single civilization. But the story does not end there. Each successful planet will eventually evolve intelligent life of its own. It may take 1 billion years or two, but eventually some of them will reach a technological level. When they do, they will look up at the sky, wonder if anyone else is out there, and then they too will begin sending their own capsules. 1,000 planets, each sending 100,000 capsules. That is 100 million capsules in the second wave. 1% success means 1 million living planets. The third wave produces 100 million. This is exponential growth. This is how life can fill an entire galaxy in just a few billion years. Scientists have run computer simulations to test this idea. They modeled the entire Milky Way, with 400 billion stars and planets orbiting each one. They assumed a single civilization begins sending biological capsules with a very low success rate, only 1 in 1,000. The result was clear. The entire Milky Way could be saturated with life in just 2 billion years. 2 billion years sounds long, but the galaxy is 13.8 billion years old. That means there has been enough time for 6 complete waves of seeding. 6 generations of civilizations, each learning from the last, each continuing the mission. The beauty of this system is redundancy. Traditional space travel puts all the eggs in one basket. Lose one ship and an entire civilization's legacy is gone. With panspermia, you have millions, even billions of backups. One star system destroyed by a supernova. No problem, thousands of others still carry the same biological heritage. A planet wiped clean by a massive asteroid impact. Also fine. New capsules will arrive later and reseed it. The system is almost impossible to destroy. You would have to eliminate every last planet in the galaxy to stop it. No single catastrophe can collapse the entire network. Maintenance cost is zero. The capsules maintain themselves. DNA copies itself. Organisms reproduce. No fuel, no repairs, no remote control. Once the system is launched, it runs forever. Deployment time does not matter. Unlike crewed ships that must arrive before the crew dies, biological capsules can travel for millions of years. In fact, longer is better. More time means more planets encountered and more chances for success. From the perspective of a civilization facing the death of its star, the choice is obvious. You do not send people. You send DNA. You do not build starships. You engineer microbes. You do not try to move populations. You encode civilization into genes and let nature do the rest. This strategy is so effective that once any civilization discovers it, every other civilization in the galaxy will eventually adopt it as well. It is the optimal solution to the problem of long-term survival. This may be why the galaxy is full of life yet silent in radio signals. Life spreads not through electromagnetic waves, but through DNA. Mathematics does not lie. Numbers do not lie. When you calculate cost, probability of success, time scale, scalability, and redundancy, panspermia outperforms every other option by orders of magnitude. This is not a crazy theory. It is the cold logic of survival. We, as humans, are now standing at the threshold of being able to carry out this strategy ourselves. We have genetic engineering. We can already send small objects toward other stars. Within a few decades, we may become the next seeding civilization, continuing the mission of those who seeded us. And perhaps we have already received a message from this process. Not a message in radio waves, but one written in light, sent across space, received once, and then gone forever. A message that, in 1977, we almost understood. On August 15, 1977, astronomer Jerry Emmon was working the night shift at the Big Ear Observatory in Ohio. He was analyzing data from the SETI program, the search for signs of extraterrestrial intelligence. Most of the time, it was nothing but random noise, faint signals from distant stars, nothing unusual at all. Then suddenly, the printer spat out a strange sequence of numbers. A strong signal. Extremely strong. Emmon stared at the printout, hardly believing his eyes. He grabbed a pen, circled the numbers, and scribbled a single word in the margin, "Wow." The signal lasted exactly 72 seconds. Its strength rose steadily, peaked, then faded away, precisely the pattern you would expect when a radio telescope sweeps past a fixed source in the sky. The frequency was 1420 MHz. This was not a random frequency. It is the frequency emitted by hydrogen atoms when they change energy states. Hydrogen is the most abundant element in the universe. Any civilization that understands basic physics would know this frequency. That is why SETI scientists have long believed that if someone wanted to get the attention of another civilization, they would transmit at the hydrogen frequency. It is the so-called universal frequency, a clear sign that a signal is not natural. The signal came from the direction of the constellation Sagittarius, near the center of the Milky Way. A crowded region filled with millions of stars and millions of potential planets. A perfect place for a civilization to broadcast a message to many worlds at once. Emmon reported it immediately. Astronomers around the world pointed their telescopes at that spot. They waited. They listened. Nothing. The signal never came again. For nearly 50 years since then, despite hundreds of observations of the same region, no one has ever detected a similar signal. That is what makes the wow signal so mysterious. If it was a message from an extraterrestrial civilization, why send it only once and then fall silent forever? Why not repeat it to make sure someone received it? Why not broadcast continuously, like a radio station? Every traditional explanation has problems. Some suggested it was interference from a satellite, but the frequency did not match any satellite operating at the time. Others proposed it was a comet reflecting radio waves from Earth, but calculations show this could not produce a signal that strong. Some say it was just a rare natural coincidence, an unusual astronomical event, but no one can say what that event actually was. Now there is a new theory, one that fits perfectly with the idea of panspermia. The wow signal was not a message meant for conversation. It was a genetic broadcast. DNA is not just an inert chemical molecule. When it replicates, when enzymes unzip the double helix, when new molecules are assembled, the process generates tiny electromagnetic fields. We can measure them in laboratories. Every living cell emits a faint electromagnetic signal when its DNA is active. One cell produces a signal far too weak to detect from afar. A billion cells, still too weak. But think on a cosmic scale. An advanced civilization, knowing its star is about to die, decides to send its biological legacy to other stars. They do not only send matter on meteorites, they send information through radio waves. They create a massive cloud containing trillions upon trillions of microorganisms, perhaps in orbit around their planet, perhaps drifting in interstellar space. Then they activate all of them at the same moment. Every organism begins replicating its DNA in perfect synchronization. Trillions upon trillions of cells, all emitting electromagnetic signals at the same frequency, at the same time. Those signals resonate and amplify one another, forming a radio signal powerful enough to be detected from hundreds or even thousands of light years away. The signal carries no message in language. It carries a biological blueprint. The pattern of the signal encodes the structure of DNA itself, like a QR code made of radio waves. A civilization advanced enough to receive such a signal could decode it, read the genetic information, and perhaps even recreate the original organisms in their own laboratories. This is biological transmission at the speed of light. No need to wait millions of years for meteorites to drift between stars. Just years or decades for radio waves to cross space. This theory explains why the wow signal never repeated. Because it was not a conversation. It was a delivery. Like sending an email, you do not send the same message hundreds of times. You send it once, complete with all the information, and that is it. The recipient either receives it or they do not. There is no dialogue, no confirmation, no back and forth. The civilization that sent the signal was not expecting a reply. They knew they were coming to an end. Their star was about to explode, or fade away. They had no time to wait for an answer from someone hundreds of light years away. They simply sent out their legacy, hoping that someone, somewhere, would receive it, understand it, and perhaps use it. The wow signal lasted 72 seconds. How much genetic information could be encoded in that time? Calculations suggest that a radio signal at that frequency, with the observed bandwidth, could carry millions of bits of data. Millions of bits. Enough to encode the complete genomes of many organisms, enough to send an entire biological library. We never decoded it because we did not know how to read it. We saw a strong signal, wrote wow, and archived the data. But inside that data may be blueprints for life forms we have never seen, biological designs from a world hundreds of light years away, messages from a civilization that no longer exists. How many similar signals have passed through Earth without us noticing? We have only been listening to the universe for a few decades. Our telescopes have scanned only a tiny fraction of the sky. If these genetic broadcasts happen regularly, we may have missed thousands, even millions of opportunities. Perhaps in the future, with better technology and a deeper understanding of how biological information could be encoded into radio waves, we will learn how to search for exactly this kind of signal. We will build telescope networks that cover the entire sky, listening continuously, ready to catch biological packages from distant civilizations. But the strongest evidence for panspermia may not lie in mysterious radio signals at all. It may lie right beneath our feet, in the oldest rocks on Earth, in structures that should not exist if life truly evolved here by chance alone. Deep beneath the ground, hidden inside the oldest rocks on this planet, lies something that should not exist. Structures so unexpected that when geologists first saw them under the microscope, they checked again and again, convinced they must have made a mistake. The Pilbara Craton in Western Australia contains rocks that are 3.5 billion years old. They are among the oldest surviving fragments of Earth's crust, formed when the planet was still a hellish world, relentlessly bombarded by meteorites and bathed in cosmic radiation far more intense than anything we experience today. When scientists sliced samples from Pilbara, ground them paper thin, and placed them under electron microscopes, they found something astonishing. Tiny tubes, only a few micrometers wide, running straight through the rock in perfectly linear paths. Uniform spheres arranged in repeating patterns. Thin filaments twisted together like tightly braided rope. The precision of these structures looks almost like nanotechnology. Diameters consistent to 1/10 of a micrometer. Identical angles of curvature. Spacing that follows mathematical ratios. This is not random mineral crystallization. This is something built, organized, designed. The problem is timing. These structures formed at a point when Earth should not have supported life at all. 3.5 billion years ago, the planet was still cooling from a molten phase. Surface temperatures were extreme, the atmosphere was toxic, and cosmic radiation poured down unfiltered. Even the simplest cell should not have survived. So who, or what, created these nanoscale structures? Some scientists suggest they are traces of extremely early microorganisms, distant ancestors of all life today. But this explanation struggles. Primitive microbes do not produce structures with this level of technical precision. They create irregular, messy forms that vary with environmental conditions. The Pilbara structures are too uniform, too orderly, as if manufactured by machines rather than shaped by biology. Now shift to another location. Sudbury, Canada, hosts one of the largest impact craters on Earth. A massive asteroid struck here 1.85 billion years ago, carving out a crater nearly 200 kilometers wide. The explosion released energy equivalent to millions of nuclear bombs. When scientists analyzed the rock layers inside this crater, they found something strange. Almost immediately after the impact, within years or decades, complex organic compounds began to appear. Not after millions of years, but nearly right away. These compounds are not the products of random chemistry under extreme heat and pressure. They show organized patterns, repeating structures, signatures associated with biological processes. It is as if the asteroid did not carry sterile rock alone, but brought with it biological seeds already programmed. When the impact created a hydrothermal environment, hot but not too hot, wet, and rich in minerals, those seeds activated. They began assembling organic molecules, preparing the next stage of life. The Vredefort impact structure in South Africa, 2 billion years old and 190 miles across, shows similar evidence. Hydrothermal activity persisted for centuries after the impact. Hot water circulated through fractured rock, creating ideal conditions for life. Mineral analysis reveals signs of biological processes, molecules that can only be produced by living cells, not by inorganic chemistry. Impact craters are not just sites of destruction. They are sites of planting. Each major impact creates the perfect environment for organisms from space to take hold, grow, and spread. This may not be coincidence. It may be design. Then there is the Rikat structure in Mauritania, known as the Eye of the Sahara. From space, it looks like a giant eye staring back at the sky. Perfect concentric circles, more than 40 kilometers across, each ring separated by a nearly uniform distance. Mainstream geology says this is erosion, softer rock worn away faster than harder layers. But the precision of these rings raises doubts for some researchers. Natural erosion does not usually produce such perfect circles. It creates irregularities, distortions shaped by terrain. Rikat is too symmetrical, too organized. Some have proposed it could be the eroded remains of an extremely ancient artificial structure, buried and weathered over billions of years. The idea sounds absurd. Who could build something that large? But the Panspermia Hypothesis offers one possibility. Not ancient humans, but extraterrestrial civilizations that engineered Earth itself, constructing vast structures to regulate climate and create conditions suitable for life. Over deep time, those structures decayed, leaving only faint geological echoes. Cave systems around the world show their own anomalies. Some caves are too uniform in shape, their walls too smooth, their angles too sharp to be explained by natural water erosion alone. Inside, minerals crystallize in patterns that some geologists struggle to explain through standard geological processes. There are rock layers where rare earth elements are distributed with uncanny uniformity. Nature usually creates uneven concentrations, rich in one place, scarce in another. Yet some ore deposits show nearly identical ratios of rare metals everywhere, as if they were mechanically mixed. When you look closely enough, Earth's geology contains too many coincidences. Too many perfect structures. Too many organized patterns. This may not be natural. It may be the remnants of a planetary engineering project spanning billions of years, carried out by those who came before us, those who prepared Earth to become a cradle for life. We are living on an engineered planet, not by humans, but by ancient cedars. Everything from atmospheric composition, to orbital stability, to continental distribution may be the result of design rather than chance. The evidence is written in stone, waiting for us to become smart enough to read it. All these pieces, meteorites carrying amino acids, optimized genetic codes, anomalous geology, mysterious radio signals, all point toward a single conclusion. We are not random. We are not an accident. We are part of something far larger, a plan that began billions of years ago, a plan that is still unfolding today. So, after everything we have seen over the past hour, let's pause for a moment. Take a deep breath. Step back and look at the whole picture. Life appeared on Earth far too quickly. The math does not add up. 600 million years to go from simple chemistry to a complex cell with 4 million perfectly working parts. The odds are essentially zero. Darwin knew this. He called it the most serious problem with his theory. To this day, science has not resolved it. Meteorites fell to Earth carrying a ready-made life-building kit. 74 types of amino acids. Nitrogen bases for DNA. Sugars for the genetic backbone. Lipids for cell membranes. Everything was there, prepackaged, waiting for the right planet. Some meteorites even contain structures resembling fossilized bacteria. Not just raw materials, but the builders themselves. Creatures seemingly designed for space exist right here on Earth. Deinococcus can withstand radiation 3,000 times higher than what would kill a human. Tardigrades survive 10 days in open space, 70% revive as if nothing happened. These abilities are unnecessary for normal life on Earth. Unless they were shaped for another environment, for another journey. Earth's conditions are almost too perfect. A shift of just 5% in our distance from the Sun and we would become Venus or Mars. An orbit that is nearly perfectly circular. A moon of exactly the right size to stabilize Earth's tilt. An atmosphere that has remained stable for billions of years when it should not have. The probability? 1 in 10,000. Like flipping a coin 10,000 times and getting heads every single time. The Cambrian explosion has no evolutionary ancestors. For 3 billion years, life was just bacteria. Then suddenly, within 25 million years, all major animal groups appeared at once, with complex eyes, brains, and fully formed circulatory systems. Darwin called this his most serious objection. Modern science still cannot explain it. The universe produces organic compounds on an industrial scale. More than 200 complex molecules drift through interstellar space. The Eagle Nebula alone contains enough organic material to seed millions of planets. The James Webb Space Telescope has detected cell membrane-like structures in regions of space colder than -400 degrees. This is not a rare accident. It is continuous production, widely distributed. The universal genetic code points to design. Every organism on Earth uses the exact same code. The chance of that happening randomly? 1 in a million. More than that, this code ranks among the top fraction of 1% of all possible codes. It is optimized to resist cosmic radiation, to automatically correct errors, to compress information efficiently. It contains mathematical patterns like Fibonacci sequences, prime numbers, even pi. Like a signature embedded within it. Viruses and tardigrades are perfect gene carriers. 8% of the human genome is viral DNA. Viruses transfer genes between unrelated species. Tardigrades carry bacteria and viruses as they travel, 20% of their genes have unknown origins. Both survive extreme conditions they would never face in ordinary life. Unless they are vehicles for transport between stars. The Kerala red rain may be extraterrestrial life. Red cells with no DNA or RNA. Resistant to extreme heat, intense radiation, total dehydration. Carbon isotope ratios that do not match Earth. Appearing after a meteor event. Similar incidents in Colombia, Austria, Sri Lanka. It may be biological delivery happening even today. Modern evidence comes from Mars and from space itself. Perseverance has found organic molecules identical to those on early Earth, with signs of recent activity. James Webb has detected organic compounds across the galaxy. Microorganisms in the stratosphere do not match known life. Bacteria grow faster in space, as if activated. Panspermia is not just the past. It is the present. The Fermi paradox is no longer a paradox. We do not find aliens for a simple, profound reason, one that changes everything. We are them. We carry DNA designed billions of years before the solar system formed. We are slowly remembering, rebuilding the technology of our cosmic ancestors. We search for our creators without realizing they are long gone, leaving only their legacy in our genes. The silence of the galaxy is not a failure. It is a success. The seeding project worked so well that its product, us, is now looking up at the sky wondering if anyone else is out there. If all of this is true, you are not a random outcome of chemistry. You are not a lucky accident on a small planet. You are a living legacy of civilizations that chose to sacrifice their bodies but preserve their intelligence, encoding their knowledge into DNA and sending it across the galaxy to ensure that intelligence would never fully go extinct. Every time you look up at the night sky and feel the urge to explore, curiosity about what lies beyond, that is not just simple curiosity. It is an ancient instinct written into your genes billions of years ago. A call from cosmic ancestors. A reminder that you belong to the stars, that your mission is not finished. We are not alone. We never were. We are part of the greatest story the universe has ever told. A story of intelligence fighting against the silence of cosmic death. Of life finding a way to survive beyond the death of stars. Of civilizations sacrificing themselves so those who come after might have a chance. A chain of inheritance stretching across billions of years, across millions of worlds, connecting us to ancestors we will never meet but whose DNA lives in every cell of our bodies. Now it is our turn to continue. We are developing genetic technology. We are learning how to adapt organisms for space. We are preparing to send life to Mars, perhaps to the moons of Jupiter and Saturn. We are becoming the next seeders. Not out of ambition, but because it is a destiny written into our genes. If this video changed the way you see yourself, your place in the universe, like it, share it. Because one of you, maybe you watching right now, could be the one who carries humanity's seeding mission forward. You might be the scientist who designs life for interstellar travel. You might be the engineer who builds the ship that carries life to other stars. Subscribe to the channel so you do not miss the next cosmic mysteries. Because this story is not over. We are only beginning to understand our true origins. Every year, science uncovers new evidence. Every space mission brings back new data. The picture grows clearer. Remember, every time you look up at the night sky, you are not just looking at distant stars. You are looking at your true home. The place where your ancestors, not thousands of years ago but billions, once lived, once looked up at their own skies, and chose to send their legacy outward, ensuring that intelligence would endure forever. We are not searching for home. We are finding our way back.